Hello, my name is June Axelson. I am the Discoverant business owner for Bristol Myers Squibb. I'm located in Devens, Massachusetts, and I'm part of the Process Monitoring and Analytics Department, which is part of Manufacturing Sciences and Technology. This presentation will highlight the work that BMS has done to create centralized management of data mappings consumed by Discoverant. I'll start by giving an overview of the source systems and data mappings in scope, go through the problem statement and objectives that we were trying to achieve, and the solution that we implemented. And then I'll give a look into the future state and the work that's ongoing now. BMS's requirements for Discoverant include regulatory requirements such as continued process verification and annual product quality reporting. We also have analytics requirements. We need a validated system to provide verified data for in-process control parameters, and we want real-time data availability as much as possible. We have process understanding and improvement requirements for investigation support and yield improvement. So the work that was done to create the centralized management of data mappings had to keep in mind these requirements. BMS has multiple source systems that connect to Discoverant, but for the first phase of this work to create the centralized management, we had two source systems in question. The first is the Manufacturing Enterprise System, or MES, that connects the electronic batch record data to Discoverant. The EBR data is retrieved from several base tables, but can be described as having a 4-level pathway. These 4 levels are the master recipe, unit procedure, operation, and work instruction. Each level can have any number of parameters assigned to it, but typically parameters are retrieved from the work instruction level. The second source system is the Laboratory Information Management System, or LIMS, that holds the QC testing data. LIMS contains information taken from samples during manufacturing. To return the data from LIMS, the Discoverant hierarchy uses a combination of LIMS metadata. Each parameter sourced from LIMS has a unique combination, or could have multiple combinations, of product, analysis, template ID, and component name. So there were 3 issues that we identified that could be mitigated with centralizing the management of the data mappings. The first is that updates to source metadata results in data gaps and the need for frequent Discoverant changes. The next is that process experts, rather than data modelers, are the ones required to populate the mappings and update them over the life cycle. We found that in practice, the responsibility was often pushed to the data modelers. And finally, the documentation, implementation, and review and approval of changes to Discoverant hierarchies can be a lengthy process. So overall, we found that with the changes in the source data mappings, we were being more reactive instead of proactive. So our objective for centralizing the management of the mappings included decoupling data analysis from data mappings. In other words, we wanted to meet those regulatory, analytic, and process understanding requirements without being dependent upon possibly long Discoverant changes. So with that, we wanted less lifecycle maintenance on the data analysis, since the requirements needed for analysis don't change as frequently as the mappings. One issue we found is that the source system component or parameter names can be unclear as to what step in the process or what parameter they're actually referring to. So with that, we wanted to use clear generic names or aliases to map to data that can be used across data analyses, including Discoverant. We also wanted to move the data mapping changes closer to the groups changing the source systems, and we wanted more timely updates to data mapping. So the solution was to create an alias database. The alias database is a repository of key pathways used by Discoverant to populate hierarchy parameters. Using the alias database, Discoverant is hard-coded with alias identifiers into conditional columns or code columns instead of the pathways. The result is that it's possible to implement mapping changes through the alias database and therefore make corrections to Discoverant outputs without making changes to the Discoverant hierarchy itself. And the benefit is that changes can be made proactively and without the need to go through Discoverant change management, resulting in fewer data gaps and faster implementation. So for MES, the alias mapping table was implemented as a database table in the same SQL server as the EBR data. You can see from the boxes highlighted there that multiple records can exist with the same data name or alias name, but with different mapping and different effective date ranges. This was created similarly for LIMS. The LIMS parameters are configured to an alias, which enables product-specific details to be maintained through primer templates. You can see in the column with parameter name, that's also the alias name. You can put the same alias name or parameter name in multiple times, but have those multiple combinations of template ID, analysis, and component name. The LIMS utilizes primer inputs in the product-specific LIMS alias page. This connection is based on the LIMS alias field in the page and the code column value in the hierarchy. So once this information is data entered and verified, this feeds the template analysis and component name to LIMS to retrieve the appropriate result. So the future state builds upon the idea of these alias systems, but builds a centralized repository with these mappings. And the benefit of this is that one, you have one central location, and this can be expanded to multiple source systems, not just MES and LIMS. It's also to be validated. It's also possible to validate that centralized repository and can be used for different consuming applications, Discoverant, but also dashboards as well. So the repository allows centralized management of data mappings that can be leveraged by Discoverant and other applications to get consistently mapped data. You can see from this diagram, the mapping repository sits on top of the data lake. The data lake ingests the external data, enterprise system, quality system data, site system data. All of the source data is ingested into the data lake. And from there, you can conduct advanced analytics, business reporting, ad hoc reporting, CPV, and CAV. We also wanted to make sure that the centralized repository served as a knowledge repository. So data mapping knowledge is embedded in consuming applications, and it can be difficult to access this information. So this knowledge repository for the manufacturing space allows for the removal of duplicate work silos and data configuration required by different consuming applications, reduced time and reduced cost for implementation of new analytics by reusing existing data mappings, consistency in data retrieval and resulting reports, efficiency in updating centralized data mappings, and it serves as a catalog of mappings for manufacturing data. So updates to data mappings embedded in consuming applications like Discoverant require IT involvement in every modification to implement changes in the development, test, and production environments. However, with the implementation of a centralized repository, we see value in multiple areas. A comparison of activities with and without the centralized repository show some key differences. And I'll get into the benefits of those differences in the next slide. So in the area of updating the data mappings, without the centralized repository, each consuming application, Discoverant or any dashboards, must be updated. Effort is replicated everywhere that needs new mappings. But with the centralized repository, the update is made once in the repository. Without centralized repository, the updates are documented as change management tickets. But with the centralized repository, it includes an audit trail that can be reviewed as needed. To implement the changes without the centralized repository, IT develops the changes in dev, installs and validates the changes in test, and installs changes in production. But with the centralized repository, there is a built-in functionality for reviewing and approving changes in the data mapping application, and the business unit can update mappings directly in the centralized repository in the production environment. For the business owner role, without the centralized repository, the business unit executes scripts and provides approval of data in development and test. With the centralized repository, the business unit reviews the data in the repository and approves new mappings directly in the system. For the IT quality management role, without the centralized repository, they're required to provide implementation approval and a review post-implementation in production. With the centralized repository, that role is no longer required. A validated workflow and electronic signature allows review and approval of changes by the business unit. So with the implementation of the centralized repository, we see significant efficiency and cost savings. We see a reduction in the number of updates required and a reduction in documentation, since centralized repository will generate those audit records. So with those savings, we see savings of time and resources. There's also a reduction in implementing changes directly in the centralized repository, eliminating development, testing, validation, in development and test. There's also a reduction in requirement for the business owner role. There's a reduction in executing testing scripts and providing approval, since those activities will be integrated in the centralized repository workflow. And there's a complete reduction for IT quality management. No ITQM review will be required for data mapping updates using a pre-validated workflow. So if we go back to the problem statement and objectives, we find that implementing a centralized repository for those data mappings can mitigate those issues. The updates to source metadata can be addressed proactively, minimizing data gaps and supporting regulatory, analytical, and process understanding requirements. The business units responsible for changes to the source system, or those who are responsible for monitoring the data, are also the ones responsible for updating the mapping over the life cycle. And centralized management of data mappings allows for a more efficient approach, reducing review cycle time significantly. So there are too many people who have worked on this project to list individually, but I'd like to thank the process monitoring and analytics team, the Devon's digital plant team, Discoverant operational support team, and the enterprise data management teams, the centralized repository and data lake team, and IT business partners. Thank you.